CloudVision Universal Network Observability, or CV-UNO, helps network teams reduce the mean time to innocence when finding the root cause of an issue. In this video, let us look at how CV-UNO collects information from various data sources to gain deeper insights. Arista EOS devices stream telemetry to CVAS, and it leverages these metrics in the network data lake to gain visibility into the network. Additionally, CV-UNO now offers visibility in the application infrastructure to get deeper insights and end-to-end visibility for the applications. In order to do so, CV-UNO deploys a sensor in the on-prem infrastructure and collects data from various data sources. It collects data from the private cloud infrastructure, Arista's next-generation packet broker, the DANZ monitoring fabric, third-party devices including load balancers and firewalls, and last but not the least, the public cloud providers. The sensor then curates and normalizes this data before securely streaming it to CVAS over gRPC Network Management Interface, or GNMI. Once all the data is in the network data lake, CV-UNO applies machine learning and its inference engine to find the root cause of the issues faster. Let us look at how are the sensor and the data sources onboarded in CloudVision. The Onboard Devices section on the device registration page onboards the Arista EOS devices. CV-UNO now uses the tab labeled Data Sources on this page to onboard the sensor and the data sources. You can click here to add the new sensor and then follow the steps to onboard the sensor. The first step creates a role with appropriate privileges for the sensor, and the second step assigns the role to the service account. A service account authentication token is generated next and stored to be used later to authenticate the sensor with CVAS. Step 4 involves deploying the sensor image in the network. Step 5 configures the sensor virtual machine, and the authentication token generated earlier is used to authenticate the sensor with the CloudVision. This process is very similar to onboarding EOS devices in CloudVision. Once all the 5 steps are executed, enter the name of the sensor that was used while installing the sensor, and then click here to add the sensor. We now notice that the sensor is communicating with the CloudVision as we see the latest timestamps when it has started streaming. The next step is to add the data sources. Click here to onboard the data sources. Select the sensor that we just installed. Then choose VMware template to add vCenter as a data source. Identify this vCenter by providing a name and then enter the URL to access the vCenter. CV-UNO uses the sensor to gather all the inventory details about the virtual infrastructure, gather metrics, and subscribe to the events via the vCenter APIs. Note that we do not need to install any agents in the virtual network for CV-UNO to get this data. Now provide the authentication details and click to onboard the vCenter as a data source. We can add multiple vCenters as data sources, and this can be seen here as we add the second vCenter. We see that the data source has yet to start streaming, but it should start doing so very soon. We now see that we are receiving the data from the vCenter. Let us now look at adding DMF as a data source. Adding DMF as a data source is optional, but the additional flow metrics that DMF provides is very useful in finding the root cause of an issue. To do so, select DMF as the template, give it a name, and then enter the credentials of the DMF controller and the URL to access it. Click here to onboard DMF, and now you see the DMF has also started streaming. We now see that the streaming state for the sensor and all the data sources is green and has been successfully onboarded in CloudVision. The Network Endpoint Overview page summarizes the entities discovered through these data sources. These include the virtual switches in addition to the physical switches, hosts in the virtual infrastructure, and virtual machines. Selecting a particular virtual machine takes the user to the VM specific page where one can monitor the VM for active events, its CPU, bandwidth and memory utilization, and packet drops. One can also get a summary of the virtual distributed switches and hosts. To conclude, we have seen how CV Uno integrates with a variety of data sources via the CV Uno sensor and provides metrics across the host and the network infrastructure for proactive risk analysis. Thank you for watching.